All right, so law of cosines. So let's have a quick recap. Quick recap of law of sines when we use it. What kind of triangles? So law of sines, we need two angles on a side, so we use it for angle side angle, angle angle side, or side side angle, and the side side angle is possibly ambiguous. So if it's possibly ambiguous, that's like double ambiguity, isn't it? Law of cosines, a little easier. At least the conditions. We're going to use the law of cosines for a side angle side triangle, so two sides and the angle that's between them, or a side 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 triangle. And then with the side 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 triangle, we're solving for angles. And like we said on the one homework problem, we can't use any of these on an angle 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 triangle because there's an infinite number of side lengths that would work for that. So what I want to do for the law of cosines, I'll give you the formula. We'll do a couple of examples using the formula. Talk about where we have to be careful with these formulas. I'll show you where the law of cosines comes from, because we know everything now that we need to know to take a look at where the law of cosines comes from. It's not difficult. And then we'll talk about, briefly at the end, we'll talk about one new formula for the area of a triangle that comes from the law of cosines. All right, so our law of cosines says if we have our triangle, and let's draw our standard triangle. Law of cosines says a squared equals b squared plus c squared minus 2bc cosine a. And we can rearrange these depending on which sides we're looking for and write this as a different formula. It's not really different, it's just we're just rearranging the letters here. So we could say b squared equals a squared plus c squared minus 2ac cosine b, and c squared a squared plus b squared minus 2ab cosine c. So again, these aren't three different formulas. It's the same formula. It just depends on which sides and angles you have for your triangle. One thing that helps, I found helpful for remembering this, is we have a squared on this side and then cosine a on the other side of the equation. And all the sides are b's and c's. So same pattern for all of these. I have a b squared here, a cosine b on the other side of the equation, and then the other two sides here. And we use this form if we're solving for a side length. We can rearrange each of these formulas. So solve for the cosine of the angle if we're solving for angles. Again, not different formulas. They all come from this formula. I'm just solving for the cosine of the angle. So I could rewrite these and say cosine A, the solving for cosine A, equals b squared plus c squared minus a squared over 2bc. And the same thing for the other ones. Cosine b equals a squared plus c squared minus b squared over 2ac. And then cosine c and we have that formula. All right. So now I have a question for you. What if our angle, yes?
The cosine c is it on the bottom?
Oh, it should be 2AB. If our angle is a 90-degree angle, what's cosine of 90 degrees? 0. So this term goes away and I have a squared equals b squared plus c squared. And what is that? The Pythagorean theorem. So if we have a 90-degree angle and a triangle, the law of cosines becomes the Pythagorean theorem. That's really an extension of the Pythagorean theorem to triangles that don't have 90-degree angles. But really, based on the Pythagorean theorem, comes from the Pythagorean theorem. So again, what I recommend is remembering one of these, and then just put the appropriate side lengths and angles in based on what you have in your triangle. And if you want to, just rename the angles and sides of your triangle. If they give you letters that you don't like for your angles and sides, just rename them as long as you're consistent with how we label triangles when we're doing these things. And then you can rearrange that one formula that you remember to get your angle formula. All right, questions on our formula? So we use these formulas when we want to find a side. And we use these formulas when we want to find an angle. All right, so let's go through a couple of examples, and we will talk about where we have to be careful with these, where I see common mistakes with law of cosines. Okay. So let's say we have a equals 5, b equals 8, and c equals 7. And we want to find all the angles. When we use law of cosines to find an angle, I'm going to suggest that we find the largest angle first. And the reason that I suggest that is because usually when we're solving, if we're solving a triangle, usually you use law of cosines once. And then you have enough information to use the law of sines to finish. And law of sines is easier to use. It's easier to set up and easier to use. But if we're finding an angle in our calculators, the inverse cosine, if that biggest angle turns out to be obtuse, our calculator will tell us, if we find the inverse cosine of something, it will tell us that obtuse angle. But if we use our calculator of inverse sine, and we should get an obtuse angle, the calculator is only going to tell you the inverse sine as an acute angle, because of the domain restriction that we made for the inverse sine function between negative pi over 2 and pi over 2. We only get acute angles. And the domain restriction for cosine was 0 to pi, so we can get an obtuse angle there. So that's why we want to find the biggest angle first, because usually we finish with the law of sines, and if we use our calculator, it's going to give us the wrong angle. All right, so what is going to be the biggest angle here? Angle B. The biggest angle is opposite the biggest side. So we want to find B first. So I go back to my law of cosines, and I say that cosine B equals a squared plus c squared minus b squared over 2ac. And I plug those numbers in, I get cosine B is a squared 5 squared plus 7 squared minus 8 squared over 2 times 5 times 7. In your calculator, when you do this process, you should put parentheses around this and parentheses around this. Because otherwise your calculator is going to do all of this, divide by 2, and then try to multiply by 5 instead. So B is going to be the inverse cosine of this number. When I calculated that number, I got 0.143. And that gives me 81.8 degrees. So this one we would have been okay, because this isn't an obtuse angle. We would have been okay, but we might not have been if it turned out to be obtuse. So let me draw a picture here. I forgot to draw the picture. I always recommend to draw your picture. So here's A, B, C. This is 5. This is 8. And this is 7. So we found this is 81.8. And now we have enough information that we can use the law of sines to finish our problem.
Wait, solve for B.
Oh, did I write it in the wrong place? I labeled my triangle differently than I did before. 81.8. Did I put the sides in the right place? Yeah. All right, so that's 81.8. So then we would use the law of sines to finish, because now we have a side-side angle, triangle, and we're going to use the law of sines. And we don't have to worry about the ambiguous case, because we already know that we have this one triangle. All right, so I'm going to say, let's find angle A. So I'm going to say sine A over 5 equals sine of 81.8 degrees over 8. So sine A equals 5 sine 81.8 over 8. Calculate that. Take the inverse sine, and I get that A is 38.2 degrees. And then do we need to use the law of sines again? No? What can we do now? Just subtract these from 180. And when we do that, we find that this is 60 degrees. And this. And we're done. So first little pointer, when you do this in your calculator, make sure you put parentheses around all of this to do your division. Otherwise you'll get answers that won't make sense. Okay, questions on that example? Okay. Law of sines is not complicated, just the formula is a little more involved than the law of sines. But law of cosines comes in really, really handy. All right, for this one we have C. Angle C is 111 degrees. Side A is 27, and side B is 18. So I'm going to draw my triangle. And we'll call this A, C. This side is 27, and this side is 18. So we have a side angle side triangle. The last one was a side 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 triangle. So we can use law of cosines. And this one, what do we want to do? Find the other two sides. Two sides and two angles. So we want to solve. And this is side C. So we're looking for side C. So law of cosines tells us that c squared equals a squared plus b squared minus 2ab cosine c. And I say c squared equals 27 squared plus 18 squared minus 2 times 27 times 18 times the cosine of 111 degrees. All right, here's another couple places where students sometimes make mistakes with law of cosines. Remember that this formula gives us c squared. At the end, you have to take the square root. It's easy to forget at the end and say c is whatever you get out of there. And that will make your triangle kind of strange. The other thing that happens is a lot of times students try to combine whatever they get by doing this piece with what they get by doing this piece, and then multiplying all of the rest by cosine of 111. Remember, all of this is attached. We're multiplying by cosine of 111. So you have to multiply this by cosine of 111 before you do the subtraction. Third place, cosine of 111 degrees. Positive or negative? Negative, since we're in the second quadrant. So the cosine is negative, so we have a negative times a negative, and you end up adding those two. So if you do intermediate steps, remember that you can get a negative here, and that would turn that positive. So a couple little places where people make arithmetic errors. All right, so I get that c squared, when I multiply this out, equals 1401.33. Did anybody else do it? Check my work. Is that what you got? Okay. So then c, we take the square root. So a lot of times students will stop there and say, oh, that's c. We need to take the square root. So c is about 37.43. And then we can, I'm not going to go through all the steps. We can use then the law of sines to find one of the other angles. So I would say sine of 111 to finish the law of sines over 37.43. And if we wanted to find side A, I'd say sine A over 27 and continue on, find angle A. Once we had angle A, we could subtract the two angles from 180 and get angle B. So what I got for this was angle A was, when I carried this out, 42.3, and then angle B was 26.7. And that would be that triangle solved. All right, questions on that example? Nice thing about law of cosines is it's kind of just plug and chug. Plug into your formula, that's it. But since we're becoming more sophisticated math students, we shouldn't say plug and chug anymore. We should say substitute and chug. Sub and chug, right. All right. Let's take a look at where the law of cosines comes from. So we saw law of sines was really easy. We can see where it comes from very easily. Law of cosines is a little more complicated, but not a lot. And it's nice that since we are becoming a little more sophisticated math students, to see these formulas as not something that gets handed down to us from heaven, but something that comes from things that we already know. So we're going to say why it works. So what I'm going to do is set up a triangle on a set of coordinate axes. It's good to know why things work, and really math is about figuring out why things work. Once you have the formulas and you're using the formulas, you're doing applied math, which is really kind of science, not really math, in my opinion. All right, so we're going to put a triangle here on this set of axes. So this is my y-axis, my x-axis. And we're going to say this is A, B, and C. And we can always rearrange a triangle so it's on a set of coordinate axes. And we're going to say this is at point 0, 0. So we're just putting one vertex at 0, 0. This entire side length is c, small c. So the coordinates of this point are c0. We're moving over c units to the right, and we're going up by 0 units. And we're going to call this point x and y. We don't know what that point is. And I'm going to draw a nice altitude in here. We've done this. We did this with the law of sines. And if this point is x and y, this side of the triangle is x. We're moving over x units to get here. And we're moving up y units to get to that point. All right. So we're going to use a distance formula between x, y, and the point C0 to find, this is A, and this is B, and that side C. So we're going to use a distance formula to find A. And the distance formula is based on what? Where does the distance formula come from? Distance formula comes from the Pythagorean theorem. That's why the distance formula works. So the distance formula says A equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So A squared equals, I'm squaring both sides, x minus c squared plus y squared. And now we have our triangle there. From our triangle, we know angle A, so we can find x and y. From the triangle, x equals x equals b cosine A, and y equals b sine A. That's the height. We use that in the law of sines. We'll find the other side, we use the cosine again. And we substitute that in here. So A squared equals b cosine A minus c squared plus b squared sine squared A. So we're just substituting into this formula. Now we're going to multiply this out. So A squared equals, when I multiply that out, I get b squared cosine squared A minus 2bc cosine A. Does that term look familiar? 2b minus 2bc cosine A plus b squared sine squared A. Now look at this. I have a b squared cosine squared A and a b squared sine squared A. What does that make us think of? Sine squared and cosine squared? 1, our Pythagorean identity. So let me put those together. So I get, and I'm going to factor out the b squared. B squared sine squared A plus cosine squared A minus 2bc cosine A. Sine squared A plus cosine squared A is 1, and we get A squared equals b squared. Did I forget a term? Oh, I forgot my c squared term. Plus c squared. I have a c squared in there. I forgot that one. When I multiply this, I get a c squared. Plus c squared. So I get a b squared plus c squared minus 2bc cosine A. And there is our law of cosine. Distance formula, which is a Pythagorean theorem, and we used a little bit of trigonometry and a trig identity, which we all know, and we got the law of cosines. So it's not some kind of miraculous formula that's handed down to us that comes out of some mysterious mysterious place. It comes from stuff that we know. All right, questions? All right, the last thing I want to talk about briefly, Heron's area formula. And sometimes you'll see this written as heroes. Herons are heroes. Heron was a mathematician in ancient Greece that came up with lots of mathematical things. All right, I'm going to write the formula, the area of a triangle, and then I'll have to tell you what the parts mean. Square root of s times s minus a times s minus b times s minus c, where s equals a plus b plus c divided by 2. And that's called the semi-perimeter. This is a lot more difficult to come up with than the area formula from the law of sines. This comes from the law of cosines. And this lets us find the area of a triangle knowing only 3 sides of the triangle. We don't have to know any of the angles. All we have to know are the 3 sides. And we can find the area. If I give you a Heron's area formula problem on a quiz or test, I would write this formula out. I don't expect you to memorize it. But I want you to be aware that there is an area formula that exists that involves only the sides of the triangle. You don't have to know anything else. All right. Any questions today? Yes? S is just called the semi-perimeter. So it's half the perimeter of the triangle. All right, our homework. So it means the form before we rearranged it, like a squared equals whatever. I'm going to add a challenge problem. All right, there you go.